All right. Good evening, everyone. I'm guessing the others are aware that we have class, so we are going to proceed. I just sent an email reminder, I guess. So hopefully you'll be able to join us shortly. Um, I know there's probably a bit of confusion in terms of the timing, but I think the by the way, I'll ask if you can hear me just fine. Certainly know you can see my screen because I'm logged on from my other device. Uh, could somebody help confirm if you can if you can if you can hear me just fine?
Yes, we can see you, Doc, and we can see the screen.
Okay, thanks a lot. Always nice to remind colleagues that class has started or something. um, in case they've forgotten, I guess I don't know. I've sent an email to the mailing list. Uh, all right, so we are going to continue our discussion of CSF 541, right? And today we're transitioning to, so I tagged the previous interaction we had as module 0 or something, because it was mostly just an info session of sorts. And so today we transition uh, to module number 1, I guess, um, which is tagged as the health data lifecycle and governance, ideally. So it's kind of like hinting at the things we are ideally going to focus on, I suppose. If I can just open this up so that I can, I always prefer to use PDF myself, and then I'll export this to PDF and then we can start, I suppose. I don't know. Took me a while here, but we eventually get there. All right. So, but before we start, just a few announcements. I know I've been spamming you with messages on both the mailing list and the WhatsApp group. What I've noticed is that there are clearly still individuals that have not they've not joined the Google Classroom site. The idea behind the site here is as we wait for CICT to help fix the number of issues associated with the official postgraduate learning management system. I'm not sure if you are aware, but the official postgraduate learning management system, and I think I may have mentioned this during our discussion of the administrivia interaction. So you get to the LMS by going to pglms, .unza.zm. But however, it appears not all students have been added to the sites, to the Moodle sites. Essentially, this runs off of Moodle, and there's still a number of lecturers that still don't have access to the platform. We're ideally supposed to use this platform because there's a directive from the DVC, academic affairs, I guess, Professor Mangala. But because we have to start, administering assessments, we've come up with a temporal measure. So we're using Google Classroom, which itself is a learning management system. Pretty easy to use or to understand interface. You probably don't have the view I have here, but I imagine if I were to log in using my personal Gmail account, I'll probably have the same view that you have, right? Which is essentially this, because my personal account has been added as a student, essentially, right? So the idea behind this is simple. So you have access to the resources, and then when assessments or assignments are administered, you also have access to the assessments via the platform itself. So you probably want to make sure that you join. I see still quite a number of people that have yet to join. Okay, so that's that about about the Google Classroom site. And then something else to mention is ideally there's supposed to be co-instructors in this course. In fact, Mshashu is supposed to take a leading role in terms of teaching the course. At some point, I think there was a bit of miscommunication. I think a mistake was made where he had erroneously been assigned to a course that Mulima Chibuye is teaching. Okay, it turns out that he's supposed to co-teach this course. And then also at some point, I believe Dr. Nirende is supposed to come through and play an active role. So that's that. The understanding we have right now with my colleagues is that I'm going to finish off the first topic, the second topic as well, and then Mshashu will continue off from there. And because if you remember, we're supposed to have a makeup session at some point. We didn't. I think we have 2 sessions that are missing. I'm suggesting that we meet either tomorrow at 14 hours. I've blocked off my calendar actually, so I'm available between 14 and 17. I'm also available between 17 hours and 20 hours. So I'm kindly asking that you liaise amongst yourselves and you let me know what or which slot is going to be convenient for all of you. Otherwise, the default for me is going to be that we're having class at 14 hours or something. Okay. Something else I thought I would maybe clarify is there is again a bit of misrepresentation in terms of what sort of course combination we're supposed to have. The people that were seemingly lost were directed to watch the recorded lecture session where we discussed this. I think it was the very first lesson that we had. And if you remember correctly, we hinted at the fact that the program itself has a total of 240 credits. And it turns out that 120 of those credits are supposed to come from part A, right? Part 1 rather, which is the coursework component. This is what we're doing right now. Part 2 is going to come from the dissertation, the research component. In terms of the 120 credits that are coming from the coursework component, we mentioned that these are ideally supposed to be, they're supposed to come from the courses that you enroll into. Okay, so both the core courses and the elective courses. And if you look at the courses associated with this program, all of them actually have or associated with 15 credit units. Okay, so if it's 15 credit units and you divide 120 by 8, well, by 15, you notice that you have 8 courses. And the logic is simple there. So the 4 credit, the 4 courses are supposed to come from this term, and then the remaining 4 are supposed to come from next term. Right? So meaning that what you're supposed to do is you want to make sure that you are attending classes, and I'm avoiding saying you are enrolled, because I know again there's a bit of an issue with the portal. Bear with us, it's still work in progress. It's supposed to be a manual process. We're hoping CICT would help automate the process, because enrollment into courses is not just affecting your program, it's affecting all the programs in the department, and we have a number of programs in the department. The only workaround we have right now is to manually add your preferred courses, one individual at a time, which is going to take a little bit of time here. And so what we are saying is, for now, what you want to make sure is that you are attending classes and you are attempting assessments in your preferred courses. So for instance, in the first term, you obviously want to ensure that you're attending classes in the healthcare systems and organization course, that's 5511, the health data management 5541, because these are our core courses, and the clinical decision support systems course, which again is a core course here. Now, to make up for the remaining 15 credit units, because you obviously need 60 credit units for this term, you must choose, right, one of the electives that are offered this term. This term, we have 2 electives that are offered. We have ethics and legal issues in health informatics. And then we have biostatistics and research methods. If you want, you can attend classes in all of these courses, all 5 courses that we're offering this year. However, in terms of computing the credit units, once you're examined or at the end of the term, these will be derived from 4 courses. Right? So in other words, what you want to do is to make sure that you attend the Tuesday class. Sorry, not the Tuesday class. You attend the Wednesday class, which is clinical decision support systems. The Thursday class, which is health care systems and organization. The Friday class, which was previously on Tuesday but has been moved to Friday. And then you choose whether you want to enroll into biostatistics and research methods or ethics and legal issues. Or if you want, you can attend classes in all of them, but when you're attempting the exam, you'd have to attempt exams in either biostatistics or ethics and legal issues. Hopefully that helps clarify things. Yeah, because I noticed there was a bit of misrepresentation here. Unless if there are any questions, we can proceed here, is it? Do people still need clarification on this? Okay, that's fine. Yes.
So I have a question. So for me, it's more of just not having registered for all the courses that you just explained. So for instance, you've said minimum we need to have 8 courses. So I don't have any electives on my confirmation slip. So I just wanted to find out how to go about rectifying that. So it's something that is appearing on my portal.
Yeah, so I think I'd mentioned earlier on when we started, maybe you just joined us, that we had reached out to CICT to see if they can have you make changes on your own, on your respective portals. However, what we've been told is that once you've already enrolled, right? Once you initially enroll into your preferred courses, making changes can only be effected manually, right? So someone from the department has got to manually make these changes for everybody who has anomalies on their confirmation slip. So this will be done. To take a bit of time, but it will be done. The thing here is that the things that are appearing on the confirmation slip for now only get to be affected when we're entering results, right? And maybe to a certain extent once the PGLMS platform is activated. What you just want to make sure for now is that you're actually attending classes and attempting assessments in your preferred electives and in all the core courses. So for this term, for instance, everybody who is pursuing the Master of Science in Health Informatics program must attend classes and attempt assessments in 5511, 5541, 5551, and then you choose whether you want to attend classes and attempt assessments in 5521 or in 5561. So your portal will be fixed. We are working on it. It's taking a bit of time here because it's a manual process, but we will work on it. In fact, we will be reaching out to just have you specify in a spreadsheet what sort of courses you want to reflect on your portal ideally. Don't know if that helps in terms of answering the question.
Yes, it does. Yes, it does. Thank you very much.
Thank you. All right, so we're going to continue. Please don't forget to reach out to me and let me know whether 14 hours or 15 hours works for you tomorrow. I'm going to be traveling on Sunday. Unfortunately, I was going to say Sunday as well, but because I'll be traveling, it's going to be a bit tricky here. Now, it turns out really that from the perspective of so-called health data management, this whole process of managing health data ideally requires some sort of information system, is it? And it turns out that there's actually a broad spectrum of health data management systems. In fact, I think most of us have probably been to the hospital at one point or the other. And if we've been fortunate enough to have visited your modern day health facility, you notice that most of the processes and procedures have actually been computerized, right? I know in my case, when I escort a relative or when I go to the hospital, it's in Minor Soko, for instance, the very first thing they'll do is they'll update my visit. If I've already been to that health facility, like for Minor Soko, for instance, they'll update their system to signal the fact that I'm being attended to on that particular day, ideally, right? In that particular instance, you notice that there's there's patient data that is updated somehow, right? So it turns out that there's a broad spectrum of systems. And what I did here is I decided to just utilize things that perhaps we are familiar with, and in fact things that I probably touched on in the very first lecture series we had when we were contextualizing the course, right? So the master facility list. I know it's a very weird way of viewing it as health data management system here, but we are managing health facility information, is it? And then there's the application that I said I was personally going to be using as a case example in the topics that I'm going to cover, which is the UTH Picture Archiving and Communication System platform. But there's more, right? You find that your typical health facility, like let's say maybe a level 3 hospital or level 2 hospital, would typically have systems that they use to manage specific aspects of the facility. It could be like issues to do with medication, right? The pharmacy, for instance, issues to do with management of imaging processes, for instance. Okay, so quite a number of things here. And so the thinking here was that before we actually even start looking at the life cycle, right, of health data, ideally, it becomes important for us to understand important aspects associated with health data management systems or health information systems, because it turns out that these are types of systems that are used to manage that kind of data, ideally. And it turns out really that the typical health data management system is actually a type or a form of, it's a specialized form of information system, right? And because it's a specialized form of information system, it ideally comprises of those 6 key aspects associated with an information system. And we'll speak to these things so that we gain an appreciation. But we have people, right? And that's the thing about people here is from the perspective of human beings that get to interact with the health data, right? So if you are, let's say, a medical doctor, for instance, and you're wanting to access, let's say, picture archiving and communication system platform, you would be viewed as a person, is it? You'd fall under this aspect of your health data management system. There's a hardware, and again, we'll speak more about this, but the idea here is simple. If you're saying that you have an information system, which we're going to call here health data management information system or health data management system, that is being used by people, because this is a piece of software, it has got to be installed and deployed on a piece of computer system, right? So a piece of hardware, ideally. And usually what they will probably tell you, if maybe you've interacted with these sort of systems at work, is they'll tell you that the system is installed on a server or something like that, right? So it's a specialized piece of hardware. In essence, it has significantly more compute resources in comparison to, let's say, a desktop computer or perhaps a laptop or something of that sort. And then there's a software component, and it turns out that the health data management system is actually a type of computer software, right? Type to that other, software applications that are required for people to actually interact with the health data management system. And a classic example in this particular case would be your web browser, right? The vast majority of information systems that are used in your typical health facility, if I can use that word or term or phrase, are web-based, is it? meaning that you're accessing them remotely. And because these systems are web-based, what you would have to do for you to access them is you need to install a web browser, right? In this particular case, I have Chrome. And then using the web browser, you can then access the piece of software, right? So the web browser is itself actually a piece of software that is required for people to interact with the health data management system. But there's more, right? There's specialized software that is required, like in the case of this picture archiving and communication system platform, it is installed on a remote computer system, server computer system, somewhere out there on the internet. But for it to be accessible, it turns out that there are certain prerequisite software applications that are required. For example, and I'll speak more about these things here, we need a web application server, right, for this to work. There's a couple of other, software tools that would be required, like system software, for everything to actually work, right? For instance, as an end user, right now I'm interacting with this health data management system. I wouldn't be able to do this without operating system software, is it? For me to be able to use my computer right now, or the first time I bought this computer, I had to install operating system software. It's a form of software that is required for me to be able to use these other application software tools like Chrome and, in this particular case, the UTH PACS platform. Okay, so there's computer software. And then there's the data part, right? This makes sense here because, a health data management system fundamentally would be used to facilitate access to health data, right? Or to enable you to manage health data or to store health data, right? So it goes without saying then that a crucial part, right, of what we're calling a health data, management system would be the data itself that is processed, right? The data that is collected, managed and accessed and all those things and stored. But also it turns out that there's an important aspect that people tend to overlook, right? The issue of processes and procedures. As you are interacting, if you're a person, as you're interacting with this health data management system, you do this within the confines of pre-existing processes and procedures, right? So a classic example here would be that maybe they will tell you that for you to access specific type of features, you'd have to be assigned a certain type of role, right? Or for you to use the picture archiving and communication system platform, you need to have appropriate credentials or something. So there's policy, right, in place, so there are processes and procedures that have got to be followed. And finally, you have communications infrastructure, right? Typically, this will manifest itself in the form of computer networks. This may not be the case all the time, but because it turns out that there's certain types of health data management systems that wouldn't necessarily depend on computer networks, right, for you to use them. However, the vast majority of them will only function if you have a reliable communications infrastructure. Usually this is in the form of a computer network. And in its simplest form, this computer network would be like your local area network, right? So it's computer network that ensures that all of the computers associated with your health facility are able to communicate with each other. Now, I mentioned something here about this being optional. And I guess an example of health data management system that I can potentially think of here is a DICOM viewer, right? So in a typical health facility, I guess, if I can use that word here, when radiologists are interacting with medical images, fundamentally what they do is they use a specialized piece of software called a DICOM viewer, right? Now, it turns out that the role of a DICOM viewer really is to make it possible for, mostly it's like a radiologist or a general practitioner to view, right? To view medical images. Now your typical health facility in Zambia currently is set up such that for a medical practitioner, a radiologist, or anybody who is interested in viewing the medical images, for them to view the medical image, what they'll do is they'll they'll typically rely on what is available on a DVD, right? So these medical images will be burned on a DVD or on a CD or something like that, right? Now, from that point of view, it really doesn't matter whether you are on a computer network or not, you still be able to access, right, the medical images ideally. There's a point I was trying to put across when I said this may be optional, but for the vast majority of health data management systems, obviously, is a key part of this end-to-end workflow of interconnected entities ideally, right? So you need some communications infrastructure ideally. In some instances, this communications infrastructure, by the way, would be the internet, is it? I'm sure most of you people that work in the health sector, in some instances, are able to access systems at work when you're at home, is it? What you're doing is you're actually accessing those health data management systems via a computer network we refer to as the internet ideally, right? So it's 6 key aspects that can be linked to health data management systems, and we'll speak to them presently here. Now, remember I mentioned here that a health data management system is a form of an information system. Well, it turns out really that fundamentally, irrespective of the type of information system you can think of, what it essentially does is it facilitates the collection of data, the processing of data, and dissemination. I want to say not data really, but dissemination of information, right? Fundamentally. We can sit here and look at examples of systems that may not necessarily be linked to the health sector here, and you begin to notice that they are all implemented to actually perform these 3 core functions, right? So for instance, Google Classroom, right, is an information system we are using to manage teaching and learning, right, processes. What are we doing here? We are collecting data about the course, for instance, about people that are enrolled into the course. That information is processed to a certain extent, and we're able to disseminate information, extract information about, or we'll be able to extract information about the performance of various people that are enrolled into this particular course, right? So at the end of it all, we'll be able to use the system to actually aggregate results that are coming in from the different assessments that are going to be administered ideally, right? Anyway, so fundamentally, what an information system does, or because we're saying a health data management system is a form of information system, we can safely say health data management systems are used to collect, process, and disseminate, collect and process data and disseminate information. And we'll speak more about the distinction that exists between data and information, right? But one way of looking at the difference here is that data is typically used as input to the health data management system. And one of the things that the health data management system will do is it will process the input data, the raw facts ideally. When the raw data is processed by the health data management system, what is outputted, or the end result, is what we're calling information, right? Things that make sense, okay? So with that being said here, what we're saying here is that an information system or a health data management system is considered to be a set of interrelated elements or components that facilitate the collection of data, manipulation of the collected data, and dissemination of the manipulated data, their information, right? Anyway, and so it's there to provide you with some feedback mechanism to meet a specified objective, ideally. Now, it turns out that your so-called information system is actually made up of, like I said, it's made up of those 6 key components that I highlighted at the beginning. And perhaps what is important here is to emphasize this notion that those 4 aspects at the top are collectively referred to as information technology, right? So they provide they'll provide a given entity the technological infrastructure required to collect, process data, and subsequently disseminate the processed data as information within an organization. Right? So the top layer, the layer that's highlighted in red here, collectively is referred to as your information technology, right? Again, we're going to look at these things in great detail here, but when you're referring to hardware here, you are essentially referring to a broad spectrum of the physical infrastructure, physical things, tangible aspects that will make it possible for you to interact with this information system. And a classic example of this tangible infrastructure that you need to interact with your health data management system or information system would be the computer systems themselves, right? So from the perspective of your typical end user in a health facility, this would be a tablet, perhaps, a laptop, a desktop computer, or these days increasingly a mobile device, a mobile phone, right? That would be used to interact with the health data management system. But something else that is interesting here is the fact that your typical or your average health data management system is typically hosted or installed or made available using a specialized piece of computer system, which is referred to as a server computer system. And so usually you would have a situation where the people that, the average end users that are wanting to interact with I'm going to call this a client, the end users that are wanting to interact with the health data management system would be doing so using their, I guess it's phone or something, smartphone, tablet, laptop or something like that. Using some network, you'd then be interacting with the health data management system made available on a server computer system, ideally. Right? So what we're saying is that the hardware here can be viewed from the perspective of the hardware devices required by end users, but also the hardware devices or the server, the computer systems that are required for you to install and host the health data management system. Right? But fundamentally, we see here that a crucial things associated with the hardware would be the computer systems, ideally. In addition to that, though, we begin to notice that besides these computer systems, there are other hardware components that would be required for you to access or to interact with the health data management system. For instance, network hardware like your router, for instance. You know, most of you perhaps work in environments where you typically would connect to the local area network using some Ethernet cable or something. So every time you report for work, you get that cable and then you plug it into a computer, right? What you're doing implicitly is you'll be interacting with the health data management system through other network devices or network hardware devices, right? And fundamentally, what these network hardware devices do is they'll facilitate effective and efficient transmission of information. If you're at home like myself today, right now, one of the network hardware devices I am using to interact with this health data management system is a router, right? So I have a ZTE router, ideally. It's a piece of hardware, something that's tangible, physical, ideally. Okay. The same would happen really if you were working from home and you're interacting with your health data management system somewhere at work or something. So you'd be accessing it by connecting to the internet via your router, for instance. And you'll notice once we get to discussion of communications infrastructure that there are a broad spectrum of network hardware devices out there. So so-called switch, for instance, is a classic example, not just a router. there are modems, right? A broad spectrum of them. Okay, so again, we're saying here that hardware essentially comprises of physical and tangible components associated with computer systems. And if we were to look at the computer hardware here as an example, we begin to notice that the computer hardware itself, or the computer system itself, comprises of different hardware components. Now, this is not a computer systems course here, but it's worth mentioning really that these computer systems that we'll be using to interact with the so-called health data management systems would be associated with components such as a so-called central processing unit, right? There's a part of the computer that does the processing of instructions, ideally, and data, right? You also have components such as working memory. I'm sure you would have heard of phrases like RAM, is it random access memory? So in essence, it's a piece of hardware that would dictate how fast, to a certain extent, how fast a given computer system will be able to operate or process instructions. In addition to this, you would have hardware components such as persistent storage devices like your internal hardware, for instance, right? Or external hardware devices. These components will facilitate the persistent storage of data. So this notion that when you switch off your computer and you switch it back on, there's certain data that you would want to still exist, right? Once you switch your computer back on, that would be stored in persistent storage. But it turns out that in addition to this, your typical computer system would also be composed of what we call input-output devices. Sometimes they'll be called peripheral devices. These would be components that will facilitate input or make it possible for us to input data to a computer system. So for instance, your microphone would be used to input sound, is it, or audio to information system. And I guess if we could relate this to health data management systems, in your modern day health facility, you find people using so-called dictaphones, right? So rather than you manually writing things down when you're attending to a patient, for instance, you'd use a dictaphone to narrate the outcomes of your visit, and then there's some information system behind the scenes that will do some fancy things like your speech to text conversion, and then all of that is automatically assembled into some report or something. A more efficient way of inputting data ideally. But the key thing here is that you would need a peripheral we call a microphone, right, to input audio or sound into your health data management system or into your information system. There are other things here like speakers and so-called keyboard and your mouse here. But again, we're not here to have a discussion of input-output devices. We're just trying to gain an appreciation of this aspect of an information system we are calling the information technology layer. And one of the key components of the information technology layer is what we're calling hardware. Okay. From a perspective of computer systems, again, we're going to look at these things in great detail at the later stage, I think as part of this discussion here, but just to mention really that there's a broad spectrum of computer systems out there. I know your average end user is probably just familiar with what we've historically referred to as personal computer systems, right? These commodity computer systems that we typically use when we are interacting with information systems. So your laptops and your smartphones, for instance. But it turns out that there are other forms or other types of computer systems. So at a later stage, we'll have a very mild discussion of different classifications of computer systems like supercomputer systems, mainframes, server computer systems, mini computer systems, and embedded computer systems, so that we gain an appreciation of how these things are important. Okay, and we'll look at examples, or try as much as possible to latch on to examples that are specific to the health sector, ideally. But perhaps the takeaway point here is that there are specific use cases where you may want to use each of these different categories of computer systems. Okay. So the second layer, if you look at the information technology aspect, is what we are calling software, right? And it turns out that when you're interacting with this health data management system to collect data, to process the data, or to disseminate the data that has been processed, in essence, disseminate the information, you require computer software, right? And in essence, what the computer software does is it will enable you explicitly specify how the collected data, or how the data is actually going to be collected, how the collected data is going to be transformed, finally, how this transformed data is going to be disseminated, right, as information. Now, it turns out that the how you collect and how you process and how you disseminate here manifests itself in what we call software features. Is it? So I'm sure when you joined wherever it is you work, if you interact with health data management systems, one of the things they did is they took you for training and told you to say, if you want to generate reports, you have to click here or something like that, right? When you click here, you have all of these different buttons that you can, use to summarize information in this manner, right? Those are called features, is it? Software features, right? They will specify exactly how things are done. Now, it turns out really that there's a broad spectrum of software tools that would be required for you to effectively use your typical health data management system or information system in essence. Right? And it turns out that we can categorize this broad spectrum of computer software. Again, if you are to look at this from the perspective of your typical health data management system, what we are saying is that there's a broad spectrum of software tools that you would need for you to be able to interact with the health data management system. Okay? A lot, actually. I already gave away an example here to say if you were interacting with something like this, which is UTH packs. We can use the UTH packs here as an example before we look at the different classification of software tools here. UTH packs. For you to use the UTH packs, you'd need, of course, this itself is a software system, but we're going to ignore this for now. Because this is a web-based application, you need a web browser. Right? In my case, I'm using Chrome. You would need an operating system. Right? I cannot use Chrome without an operating system installed on my computer. Right? I am using, not that it matters really, but I'm using an operating system called Ubuntu, right? In all likelihood, most of you are probably, if you're logged on a computer, you're probably using some version of Windows or something. I don't know what versions are used right now. So I'll use Ubuntu as an example, maybe Windows, for instance. Right? What else? Well, there's certain types of software tools that perhaps you're using implicitly, but we're going to focus on things that you probably directly interact with, right? I'm trying to think here. Well, on the side of the UTH packs itself, I would probably need a web application server. Right? Web application server. It turns out that, it turns out that the UTH packs here is a modified version of an open source platform called Authank. And I don't know if Authank has Authank. I don't know if Authank has a GitHub repository. I think it does though. If you look at how Authank, I don't know if it's Authank Explorer here or is implemented, you begin to appreciate that. I don't know whether it's this or this. I essentially wanted to check the technology stack here. So it turns out that Authunk is, not that it matters here, but Authunk is implemented using a programming language called Python, right? Now, because Python is what we call an interpreted language, for you to be able to successfully run or to run applications created using the Python programming language, you need a Python interpreter, right? Which is a piece of software. So if I wanted to run Authunk, the one that is installed on some remote server out there, I would need on my computer, this is my computer right now, I would need to install Python, which incidentally I already have installed here. The version of Python I have, right? So it's a piece of software, it's an interpreter, it's a piece of software that is required. What else? There's a web application server, obviously, which does make sense. Of course, on the side of the, I'll just call this the client machine or something like that, or the user. And then on the, I'll call this the server side, the server machine or something. This is a remote machine. Right? So you need a web application server and a whole slew of other, applications. But simply put here, you begin to appreciate the fact that software is an integral part of, there's a whole range of software tools that are required for you to be able to interact with a typical health data management system, which incidentally, the health data management system itself is a piece of software, right? The thing that you're interacting with. Anyways, it turns out that what we are calling software can actually be categorized into two broad categories. And we're going to go through these things in more detail so that we appreciate, the background, right, of what it is we're doing here. But it turns out that we can look at all of these different types of software from the perspective of the two broad categories of computer software. And so there's what you call application software, and then there's system software. What we're calling application software is the software that we interact with directly for us to tell the machine or the computer what to do, right? So things like Chrome, things like Google Docs or Microsoft Word, things like, what am I using here? PowerPoint, right? Things like Kate or something like that, right? All of these comprise application software. And then you also have system software, right? So this would be application software tools that would directly interact with the hardware itself. Right? So like your operating system, for instance. It's a classic example of system software. Anyways, the key thing here is that application software does not, when you're interacting with application software, you're not directly interacting with the hardware, but rather you are passing through this go-between software we're calling system software. And again, when we look at the specific, specifics of application software, I have a dedicated discussion of this later during this lecture series, but you will notice that things like the interpreter itself is system software. Your web application server is application software. Right. The thing we are calling the health data management system is application software. The operating system is system software. The web browser is application software. Right? If that makes sense. And at a later stage, you begin to notice that this application software can further be categorized into subcategories, is it? We have desktop applications, things that you have got to install, right? And later on, interact with. Like if I'm manipulating images, I'll use tools like GIMP. So you double click on a .exe file or I don't know what the extension is for Mac here. Is it DMG or something like that? I don't know. And you go next, right? To install it on your computer. It's called a desktop application. You also have web applications. Increasingly you have applications that are made available as software as a service. You have plugins, so a whole slew of different types of application software. And also, when you look at application system software, you notice that you can subcategorize them, right? There's operating system software, there's firmware, you know, and a whole range of other, you know, system software tools like so-called translators or language translators, right? These are tools that will enable you to convert, let's say, from a software represented in one form to the other. Like, for instance, we would want to convert software instructions when created by a human being into a form that a computer will understand. So from a high-level language or high-level representation to machine code, for instance, if this is making sense. Anyways, right? The key thing here is that software forms the second layer, right? The second layer of what we are calling the information technology layer. All right. And then you have your communications infrastructure. Ideally, it is there to facilitate the transmission of data, right, from one machine to the other. And it turns out that, you know, a lot of things that we use these days, right, have been so abstracted that sometimes when you're having a discussion like this, it may seem like fiction, is it? It turns out, if I was to use an example of what is going on right now, right? We are having an online class. You know, you have a range of people that are connected to this online class. And in essence, what is happening is, as I am speaking right now, right, as we're having this interaction, you are able to see what I'm projecting on my screen. That's one thing. And also, you're able to hear the things I'm saying. Now, it turns out that all of these things that are coming from my side to you can be perceived as data. In fact, they're data, right? They comprise of data. Now, the way this data is transmitted is actually quite interesting. It's so let's just look at a simple example, like I'm going to use a text message here. I'm going to use a text message here. I'm using WhatsApp, right? And then there's me, and I'm about to send the word hello to my mother or something. It turns out that the things that I would be sending to her phone, I'm not really, it's not like I am the one who's sending the word hello to my mother here, right? But I am using a machine, right? Is it a computer? My computer or my phone is the one that is being used to send this message to my mother's phone, ideally. Now, it turns out that when this is being sent, at a very low level, what is happening is the message I'm sending would be broken up into so-called packets, right? So much so that when the packets are broken down here, they are transmitted via a computer network as data packets, they're called. And usually you can gain a sense of what is happening here if you use tools like ping. Let's say I wanted to ping www.facebook.com or something. It kind of shows you the path that the data packets, maybe trace path or something, the data packets that are originating from my computer would take, right? When I'm interacting with Facebook. So I'll just press route or something. Trace path, right? And so they're broken, the message is going to be broken up into so-called packets. And it is these packets that are at a very low level, they'll be converted into ones and zeros, and then they're sent as signals. And then on the other end, they're reassembled, right? Then you have this illusion that what you're receiving is a word hello or something. But anyways, it turns out that for these things to be transmitted, for data to be transmitted, you need some communications infrastructure, right? And usually when we're dealing with information systems or health data management systems, this communications infrastructure is in the form of computer networks. Anyways, hope this is making sense. And really, the communications infrastructure is the one that facilitates, exchange of data in between what we are calling computer nodes or hosts, right? So these computer nodes or hosts would be computer systems and other hardware devices that would be sending and receiving this data. If I were to use my example again, when I'm accessing the UTH PACS, right, a health data management system, what is happening is I'm using my laptop, a ThinkPad laptop. My ThinkPad laptop is connected to a router, a liquid telco, a liquid technologies router. The router is the one that gives me access to this large computer network we call the internet. And then from there, the data packets are being sent to the computer system, the server computer system somewhere out there on the internet, which is used to host this health data management system we are calling the UTH PACS, ideally. So quite interesting stuff here, right? A thing to appreciate here, and I've decided to include a very lengthy discussion of the communications infrastructure. So we'll look at computer networks just briefly, just enough information for us to get an appreciation of what is required for you to be able to interact or to use a health data management system. So we'll look at computer networks and types of networks and protocols that are used and all those things here. But really what we are saying here is that this data is exchanged between network nodes or hosts. All of these are called network nodes or hosts. And these devices really facilitate the effective and efficient transmission of the data. Another important point to note here is that what we're referring to as network nodes or hosts are not just computer systems, is it? There are other hardware devices like routers, switches. I'm sure you work in environments where you have network printers, is it? So you have this one giant printer which is perhaps located in a central location, and every time you want to print, you just send the print command, you specify the IP address of the printer, and then the print command will be executed on the printer. You go and pick up the printed copies of whatever it is you're printing, right? Anyways, so quite a number of things there. Maybe something else worth mentioning is if you're looking at so-called computer networks, quite complex because we are landlocked, right? We know this. One of the questions you should be asking yourself is, when I'm, let's say, interacting with, and I'm just going to assume here, let's say there's in fact, let's not just say, let's say there's a health data management system. Let's say you're interacting with this I don't know if it's moh.gov.zm. I don't know if it's HTTP or something. Or maybe it's just this. So www. I mean, we can arguably view this master facility list here as a health data management system, right? This is arguably health data, is it? Although it's data about health facilities, but it's health data, right? It's like when you're interacting with this, which computer networks do you get to interact with, right? It turns out that you can trace the path of, I don't know if we can trace the path here. Let's say trace route online or something. Let's see if we can find a nice way of trying to trace the path route. Trace route website online, something like that. I don't know. I want to see if we can figure out a way of I don't know if I can check this site here. Master facility list. I don't know if this is going to work here. It's not working here. How about target host? Is this? Let's run. So what I'm doing here is I'm trying to see, the path I'm taking to essentially access the master facility list. Why am I checking this? Well, I'm not on the same local area network as this machine, is it? It's installed somewhere on a computer system somewhere out there. I don't know if it's on servers at Ministry of Health or something, but I'm going to trace the path here and try. I don't know if this is going to work here. It's taking a while here. But in essence, I want to see as this thing is running, I can also run on it's here. Beautiful stuff. Look at this. This is so sad, right? I have a colleague, by the way, who conducted studies that seem to suggest that when we are accessing services on the internet, it turns out that for the most part, even if the service is in the same country, in this particular case, its master facility list here is in Zambia, right? But look at this. I don't know if you can see here. I'm going somewhere in Europe, if you notice here, right? I'm going somewhere in Europe, and then I go to, where is this? Is this North America or something? And then the data packets come back to Zambia, right? And in essence, these are some of the network nodes that I am passing through for me to gain access to the server, right? You notice here, quite a number of machines, and then eventually I access, I don't know what this is here. I access some server, but where is it? The target is this, but I'm passing through a number of machines, is it? Now, the reason I'm mentioning this is that if we are saying, it's not really like, if you look at this visualization here, when they say the network traffic here is such that it takes you to Europe and then somewhere in North America, and then it comes back to Europe and then finally back to you here. Because the nice thing about this is the server I'm accessing is right here in Zambia, right? That's one thing. It's in Zambia. I am also in Zambia, but I'm accessing it by passing through the internet. And for me to gain access to it, I'm passing through these network nodes that are located in Europe and North America or something like that. Very weird stuff here. Now, what I'm trying to say here is if you look at this relative to computer networks, we are landlocked, right? So in as much as this visualization is telling me that my traffic is terminating in Europe and also North America, it doesn't necessarily mean that the signals are flying off in the air or something and going to Europe, and then from Europe they're flying in the air and then going to North America. It turns out that a lot of effort has been put into laying physical infrastructure, like actual physical wires, right? That are used to transmit these signals. So I'm pretty certain you've heard of, people talk about, fiber and stuff, right? In fact, if you look at entities like Fibercom, you notice that they'll provide you with a map that showcases how Zambia is interconnected. I don't know if you're aware of this thing. Oh, it's not there. I wanted to see a map that shows how Zambia is interconnected. So in essence, what they're telling you is for these nodes here that are interconnected, you literally will be able to send signals via a wired communication medium and not wirelessly. And the advantage of using a wired communication medium here is it's much faster than sending signals wirelessly. I think we know that, right? This is one of the reasons why on a local area network, most of the computers will be interconnected using those wires, the Ethernet cables and stuff. Your Wi-Fi would typically be much slower than that. But it turns out that in as much as Zambia is interconnected like this, the question is how exactly are we interconnected to the rest of the world, right? There are these physical wires. So for instance, there's fiber cables that have been laid from countries that are not landlocked, like South Africa, which then will subsequently have wired connections to other parts of the world. So what you're seeing here, underwater sea cables. I don't know if you've heard of these things, the underwater sea cables. In fact, at some point, there was a lot that was being talked about how Russia, for instance, was sabotaging. They were cutting Russia underwater sea cable or something. Apparently, they were cutting underwater sea cables, right? And, you know, there's a lot going on in the world here. But anyways, so it turns out that the way that we are ideally connected to the outside world is everything that we do, insofar as the internet is concerned here, your traffic ideally would typically be sent all the way to South Africa, and then South Africa is our gateway to the outside world. Right? In fact, you have other entities that have set up connections like Zamren. I don't know if people have heard of Zamren. Zamren is there to interconnect I'll just say Zamren Africa Network, to interconnect traffic from Africa, for instance, to other parts of the world, right? So you'll be able to find, it's unfortunate that there's, Zamren has this nice diagram here. So it showcases how Zamren will make it possible for universities. Zamren is specifically tailored towards higher education institutions, all right? Like UNZA, you know, Zikas University, UNILAS, you know, Zambia College of Medicine and all those things. Anyways, I don't know where that thing is. This is what I was looking for here. So this kind of shows you how Zamren, which is here, is interconnected with other parts of the world, is it? So there's fiber that enables us to interconnect with our neighboring countries, for instance, but also you see that this network I was showcasing here is the same, right? These are the same underwater sea cables, if you notice. Is it? Anyways, so there's that, right? The key thing, though, is that what we are saying here is that for us to be able to effectively use what we are calling as a health data management system, right? So that we gain access to health data or we manipulate health data, there are important aspects, right, that we need. Chief amongst them is the information technology layer, which comprises of hardware, software, communications infrastructure, and data sources. We so far discussed the hardware component, software component, and we're just wrapping up the communications infrastructure layer, ideally. All right, and we're going to look at these things in detail just now. But we see here that we made mention of the fact that a health data management system ideally is there to facilitate the collection of data. It's there to facilitate the processing of the collected data. It's also there to facilitate the dissemination of the processed data. You disseminate this as information. And you notice here that what you're doing, right, what you're doing here is, if you look at the of the health data management system, what you're doing here is you're working with one crucial ingredient, which is data, is it? You collect data, you process data, you disseminate processed data. And it turns out, right, that for you to be able to process the data and to disseminate the processed data, that data has got to be stored in a special kind of way. In other words, it has got to be persistently stored. Right? So stored in such a way that it will always be there. And there should be some guarantee that that data is going to be available if somebody wants to access it. Right? So you're storing it permanently, right? It will persist. And the word persistent really comes up because computers work in a certain type of way, right? There are certain memory structures which don't persist data. I'm sure you have, although computers are evolving like that now, but if you are, let's say, typing, right? You're typing using a word processor, for instance, and for some weird reason, Zesco does its thing and there's a power outage and your computer switches off. You didn't save like that. That information will disappear, right? Because you did not save it. When you save, your data is going to be persistently stored. And typically it's stored in secondary memory, right? The things we call internal hardware or something, or external hardware, hard drive, and all those things. Now, we see here that the data that is collected, the collected data that is processed, the processed data that is subsequently disseminated has got to be persistently stored in some storage medium, right? So that it's always accessible, it's always there. And it turns out really that there's different approaches that can be taken for that data to be stored persistently. Chief amongst them is what we're going to look at later on. I think we're supposed to have a discussion of relational database management systems and all of those things, if you remember my walkthrough, right? It turns out that relational database management systems will make it possible for you to store data in relations, is it? So it's small little entities that have some kind of relationships. This will make sense, I think, when we look at relational database management system. But the idea really is, if let's say you're handling data about health records, let's just say health records, right, at a hospital, you begin to notice that the health record here has a number of different aspects to it. You have the patient, you have details to do with payments, right? Nobody accesses these services for free, is it? Yes, there's NEMA, but NEMA is not free. You have issues to do with the doctors, right? You may have issues to do with medication. And so the way a relational database management system does is it will actually store these records in such a way that all of these different aspects or data types are linked somehow. Typically, an easier way of linking this sort of information here is you'd use something that is common amongst all of these, right? It's a patient ID. So all payments would be tied to patient IDs, right? So I'd say this payment was made by a patient with a patient called Lighton, and Lighton has a patient ID, this, five ones or something. You have also the patient name, patient, it's a patient age or something like that. The whole 9 yards, right? Patient next of kin and all those things, right? And you notice here that when information is stored like this, you can generate information on and about the patient, is it? It's like, which doctors have attended to Lighton in the last 6 months? Let's say type service. What sort of services has Lighton accessed at our health facility? Oh, he has had an X-ray taken or something. He's had lab tests conducted and all those things, right? And then you can interlink them. Anyways, so the key thing here is that data stores, and I don't want to say databases here, but data stores, because it turns out that these records can also be stored on a flat file, on a file system ideally. They don't necessarily have to be in a database, right? But usually a database is a common way of storing these records, ideally. Okay, so the key thing here is that there's a broad spectrum of data sources that are used to store this data. Again here, just to mention that if we were to look at this example here, the master facility list, I'm accessing this health data management system using this URL. But it turns out that all of this information I'm accessing, look at this. I want to check which facilities are available in Eastern Province. And specifically, I'm interested in Chipata because my parents are based in Chipata or something like that. All of this information that I'm accessing here is it's persistently stored somewhere. And guess what? I think we can make an educated guess. The persistent store that is used to store this data here is a database, right? It's a database. It's a relational database management system, actually, most likely it is. right? So somewhere in that database is you have details of facility name, GPS coordinate, and all those things. I don't know. GPS coordinates could be used to render. Usually you have a map somewhere, right? Don't know, a map that showcases where that facility, come on, is located and stuff. I don't know if this is making sense. And it appears, where is this? Oh, Mazumo Goman and stuff. I don't know what this is. You know, including the longitude and latitude and stuff. All of this information will be in Tizwa. I've never heard of this facility. They'll be stored in a persistent store we call a database, right? This is kind of like making sense. I'm gonna pause here and maybe just find out if any questions. All right, if there are no questions, we are going to, again, just to mention that we will we have an extensive discussion of of these layers here, is it? The aspects of your so-called information system, so that things make a lot of sense here. I think I checked somewhere. I don't know if I did. I had looked up. I think I'd looked up Authentic or something like that. I don't know if people remember here. I was looking up Authentic and no, I think it's here. You notice here what Gemini is telling me is it's giving me an idea of what sort of languages are used and stuff. Look at the part that says database and storage. Huh? Authentic is the framework that was used, that is used, or that we used to implement this. This picture archiving and communication software platform. And so what we are saying is that all of this information that I'm accessing here, where is that? Here, this, right? When I access this platform from here, you say, oh, I can log in and then I can search for studies, the details about these medical images and stuff, right? All of this information is stored in a relational database management system. A relational database management system, which by default, when you're using Authentic, it can be SQL-lit. If you remember, I said the relational database management system that we're going to use in this course is going to be SQL-lit, right? And it's quite easy to use, really, when you install it, SQL-lit 3, yeah, right? This is what you'd be using, ideally. But you can also use PostgreSQL, ideally. But anyways, hopefully this is making sense, right? We have an idea of the top layer here, the information technology layer, which comprises of 4 key components. There's hardware, there is software, there's your communications infrastructure, there's your data source, right? In addition to the technology, information technology layer, there are 2 additional aspects associated with health data management system or an information system, because the health data management system is a type of information system. Key is the people aspect, is it? And really, when we're referring to people, what we're doing is we're referring to the different roles associated with an information system. In essence, the people that would be responsible for collecting the data, the people that would be responsible for processing the data, the people whose sole purpose at work is to generate information from the data collected. So you're disseminating the information. There are usually people in a typical organization that whose role, if you look at a health facility like UTH, I'm sure there are people that whose job is to analyze the data and then they come up with those reports, quarterly reports. Well, in the in the radiology department, we had a total number of a total number of maybe 1,000 X-ray examinations. A number of CT scans were maybe 500 or something in the last quarter and all those things, right? So it turns out that what they do is they're interacting. For you to perform all of these different functions associated with the health data management system, you are associated with a specific role ideally, right? And really the role determines or dictates how these people would use or would interact with the information system. Okay. It turns out that besides the people that directly use the information system, there are other important people, is it? Like probably where you work, your workplace here has an IT department, and whenever you are unable to access some health data management system, you make a call to IT or you raise a ticket like we do, right? No, I have a problem, I can't access the system, or the system is slow. It turns out those people play a certain role, right, insofar as the information system is concerned. So their role would be to maybe maintain, right, or administer the system, manage the system. But also, it's important to appreciate the fact that if you look at the health data management system, before its initial use, there are people that develop that piece of software, right? So all of those are key players, ideally. They comprise of people associated with the health data management system, ideally, right? So there are all sorts of roles here. You have, business analysts, the people that would be gathering requirements that would dictate exactly how this health data management system should be implemented. You also have the programmers, the people that would actually implement the piece of software. There are quality assurance engineers, the people that would test that the software implemented, the health data management system, works as desired. And then you have end users, right? Nurses, for instance, data entry clerks, depending on the type of health data management system you're looking at here. People that will be, whose responsibility is to collect data. Sometimes the data collection is implied, right? Like for instance, if I go to Unza Clinic when I'm sick, probably a nurse is the one who's going to collect the data, is it? If I'm visiting Unza Clinic for the first time, they'll typically, well, I don't know if they still open a book. You haven't been there in years here. Last time I went there, I don't know if they opened a book here. When I was starting work at Unza some 8 years ago, is it 9 years ago or something now? But a nurse for a clinic like Unza, a nurse is the one that initiates the data collection. So they're collecting data about the patient. So they'll ask you, fill out this form, or, when were you born? What is your NRC number? And what sort of information they collect as well. What are your names? Crazy stuff like that. What they're doing there is they're collecting data, and they are all really, they are end users, is it? You'd be an end user. The point I was trying to put across here by including all these other roles is that when you're interacting with the health data management system, when you start talking about users, the first thing that comes to mind are the end users, right? Nurses, doctors, public health experts, radiographers, radiologists, right? Surgeons, the whole 9 yards, right? General practitioners and stuff. But what we're trying to say is that there are other roles that are important. System administrators. The system is not accessible, or it's very slow. A system administrator will log in and play around with the system, debug, right? The network is down. Your network administrator will be there, right? To work on the network so that you're able to interact with your data management system. My computer is slow. Your user support engineer will come in and look at your computer. and all those things. Anyways, hopefully this makes sense about the people layer. But we see here that in addition to the information technology layer, which comprises of 4 components: hardware, software, communication, infrastructure, and data sources, we have people, and then finally, we have procedures. When you have an important piece of software, we are calling a health data management system, there are typically rules and regulations that govern how that piece of software should be used. In some instances, there are sensitive applications where they will say, this system is only accessible within the local area network. So when you're at home, you'll not be able to access the piece of software. It doesn't mean that it's a constraint associated with the software. The software can actually work, or you can actually interact with a piece of software when you're at home, but the procedures, the rules, and the regulations dictate that you can only use that piece of software when you're at work. There are certain rules and regulations, like I have heard, some colleagues have told me, and I think it makes sense, right? There are certain health facilities, in fact, some health facilities that will attend to people we deem very important in this country of ours. I'm not important myself, but if you go to Mainasoko, for instance, the important people that will go there, right? Chiefs, ministers, past presidents, and all those things. The rules and regulations that you have there could dictate that only people with certain types of roles can access records associated with those very important people, if that makes sense. So even if you're a general practitioner, for instance, if you've not been assigned to attend to maybe the president or the minister of finance, when it comes to Mainasoko and you attempt to access their file, you'll be locked out, right? There are procedures that have been put in place. Now, really, all of this, the layer we're calling procedures here is talking about the rules and regulations that govern how this health data management system should be used. And really, most of these things are really contextualized to the health facility or the entity that is using that health data management system. If that is making sense, you know, in some instances, these rules and regulations may be general guidelines that apply to just the health facility. In some instances, it could be regulations, right? That have got to be adhered to. I'll give you an example. In the Republic of Zambia, we have legislation, right, in the form of the Data Protection Act of 2021. If you read this document, I think I mentioned this in the very first beginning of this. If you read this document, there is mentioned here boundaries, border. I don't know if I'll be able to find what I'm looking for here. There's legislation that says a data controller. So a data controller here could be like UTH is a data controller, right? Let's use UTH as University Teaching Hospitals as an example here. Shall process and store personal data on servers and data center or data center located in the Republic of Zambia. Meaning that I've been to Mainasoko myself before. My records, they have a record about me, right? Because that record has details like my NRC, my name, right? That information can identify who I am, right? So that's personal data. Mainasoko is not allowed to store that type of data on a computer system that is located outside of the boundaries of the Republic of Zambia. So in other words, the server computer systems that they use to store data about patients like me should be located in Zambia, right? That is part of what we are calling procedures, is it? And they fall under the broader confines of what we're calling regulations, right? Compliance and regulations. In this particular case, national legislation. Now I know, right? It's crazy what people do here. And I hope some of you don't do this. You're doing the wrong things and you've used as an example. you're working from home, right? There is this, maybe Department of Radiology does a scan, and because you're in a hurry, right? No, please send it via WhatsApp. And they send the medical image via WhatsApp. Hello? Well, maybe not one. Save it on Google Drive, right? Just put it on Google Drive or something like that. Well, Google Drive servers are not located in the Republic of Zambia, right? They're not. They're out there, right? Outside the boundaries of Zambia. So when you're doing that, you're doing the wrong things. Or you'll be like, no, send it to my email, right? That's wrong, right? Because we know that your emails, right? If you access Gmail, most of us don't even use yeah, most of us don't even use we don't even use institutional assigned email addresses, is it? We use personal Gmail addresses. Well, guess what? Gmail, right? The things in Gmail, mail.google.com, these servers are not located in Zambia, right? If you want, actually, you can use this same thing here. I got mail.google.com. We can use the same service I was using before here when I was tracing the path here. You can check where are Google servers here. Where is this located? You notice that it's not in Zambia, right? So you're doing the wrong thing. But in other words, compliance, right? Very, very important. Is part of what we're calling procedures, ideally. Best you're not used as an example here. Just make sure you're doing the right thing here. But that's okay also. But besides, general usage guidelines, how you're supposed to use the system, you can only use it on the local area network. Or there are certain sensitive applications, right? You can only use them when you're using a company-issued computer system. Weird applications like that. But there are also procedures that dictate things like user roles and responsibilities. If you are a nurse, you shouldn't be given roles in the system that will enable you to gain access to all the information about that patient. Right? Why should you do that, right? If you're a pharmacist, if your role is to dispense drugs, medications, why should you have details about lab tests, right? So there'll be processes and procedures, and usually about how, what sort of features of the system, how this health data management system should be given to specific types of users, right? Typically, a document will be prepared, process and procedure document, that will outline if you're a doctor, you have access to this, this, and that. If you're in management, I've been to Mainasoko before, sometimes you are told, go to this department to sort out issues to do with money. If you're a doctor, why should you have details about payments, right? You shouldn't actually be concerned as to whether a patient is on a medical scheme or not. That has nothing to do with you, right? So your role will be assigned a role that does not give you access to financial records about the patient or something like that. Anyways, that's that. But also, procedures could include things like O&M procedures, is it? How the system should be managed. And really, we are talking about your system administrators, the people that make sure that the system is up and running. What activities should they perform to make sure that you don't have a situation where the system is down or the system is slow, right? That's operation and maintenance. More importantly, issues to do with how data should be handled. It should be regulation, is it? Procedures that dictate if you are sharing information between Mainasoko and UTH, this is what should be done. When we capture personal identifying information, or when we capture records, patient details or records, we should store them for X number of years, right? Your retention period. Your retention period will typically have got to be explicitly stated in some document somewhere, so how data should be handled ideally. If there's a researcher that comes through to your health facility or to UTH, and they're conducting research that requires that they gain access to patient details, what process should they go through? How do you share that data? And maybe we say the rules will say, well, we have got to anonymize the data, right? So that that data that has been given out cannot be used to identify people, specific people in society or something like that. Anyways, I'm not really sure if there's any questions about these components. Very, very soon we start going through these in detail. But I thought we would have just a gentle introduction to these key concepts before we proceed. Any thoughts or questions about this? All right. I'm assuming everything is clear then. Okay, that's fine. Now, I thought before we start going through these things in great detail here, which is very, very soon, I guess, I think, I thought it would be it would be nice for us to make mention about some of the key components associated with health data management systems, right? Now that we have an idea of, what actually, what are the key aspects of your typical health data management system. It's essentially a type of information system. And so, we have these 6 key aspects: is hardware, software, communication infrastructure, data sources, people, and procedures. We know what role of these things play. We have an idea. A thing to appreciate here is that there are different types of health data management systems, right? The thing they have in common is that they are ideally all used in such a way that they help manage health data ideally. Is it? And so we can think of these things we are calling HDMSs, or health data management systems, as digital frameworks, right, that are used to systematically collect, store, analyze, and secure patient, administrative, and clinical data. Now you begin to notice here, right, that what we're doing is we're just expanding upon our definition of what we introduced as an information system, isn't it? If you remember, I'm going to double back here and remind us that we said that an information system, right, is used, right? It's a computerized system that is used to collect, process, and disseminate data in general. However, we are defining a health data management system as a digital framework, which may include, by the way, systems like electronic health records, right? Electronic health data management systems and clinical data repositories. Fundamentally, these health data management systems are used to systematically collect, store, analyze, and secure, I want to say, and secure health data. Okay? But we're expanding upon this to say this health data includes things like patient data, right? Administrative data. So patient data here could be details to do with lab results or lab tests, vitals. Every time somebody goes to their vitals, those things are stored somewhere persistently, right? That's patient data. Administrative data, how much money was made from CT scans, or if you look at the different services that we provide, right? The lab, the pharmacy, I don't know what other sections you call here, but how much money is coming through every day or every month or something. That's administrative data. How many new people joined our health facility last month? That's administrative data, is it? HR-centric data, for instance. How many doctors do we have? How many nurses do we have? That's all administrative data. But we also have clinical data as well, right? But fundamentally, what we're saying is that these things we are calling health data management systems are digital frameworks that are used to systematically collect, store, and analyze. So systematically collect, store, analyze, and secure health data as a broad spectrum of health data. Fundamentally, what they do, right, by facilitating, the collection, storage, analysis, and secure storage of health data, what these health data management systems effectively do is they facilitate improved patient care, which obviously makes sense, is it? When I'm sick, instead of having me fill out this paper-based form, right? Hence delaying the process of me being attended to, you use some digital piece of software that will make it possible for me to be attended to efficiently. Subsequent, what you're doing is improving patient care. I've been to certain places, very efficient, right? You go there and they have a fingerprint reader, is it? Like Coptic, I think I've been there. I took my mom there at some point. Has she been attended to here already? Yes, okay. Fingerprint, boom, and then they find a record like that. Compare and contrast, no, what is your patient ID? Read it out to me, right? You're delaying progress there, okay? Anyway, so you are improving patient care. You are facilitating real-time decision-making, right? Because these records are electronic form and they've already been summarized. You're able to make effective decisions, right? You have access to real-time data, actually. As information is being captured, you actually have access to that information. If there's an agent meeting that has been convened by executive management and they ask a simple question, how much money did we make last week or something like that? Somebody can log into the system and pull out that information, real-time information. Or how much money have we made so far this month? Today is the 13th of March, right? How much money have we made so far this month? There's an emergency meeting or something like that. You pull out that real-time data ideally. Maybe you're about to make a decision on whether to remove Unzalaru, right? Because they haven't been remitting their funds. Let's remove them here or something like that. I don't know. But also, it turns out, right, that these health data management systems will also facilitate inter-facility reporting. This typically happens in situations where these facilities, different facilities, are interconnected ideally. Okay. In some instances, I don't think we've gotten to this stage yet, but we're getting there as a country, right? What will happen is this health data management system, what typically happens is they will typically be integrated with cloud-based infrastructure and what's called the Internet of Things technologies, ideally, right? Anyhow, now this brings us to our discussion of some of the key components associated with what we are calling as health data management systems, is it? And key components and types here, right? In terms of specific types here, would have things like electronic health records, right? Or electronic medical records. Ideally, these will comprise digital patient records that are used for clinical workflows, documentation, and treatment. Okay. And then what we're referring to as health management information systems would be essential information systems that are used to collect, analyze, and evaluate health data, right? Either at facility level, in some instances at national level. And you'd be utilizing systems that perhaps you've heard about these things, right? DHIS2 or something like that, to be able to visualize and report. In an ideal case, what so-called progressive countries have done is they've interconnected all health facilities, right? I want to pause here and maybe just ask if we've gotten to this stage here. For the experts in the room here, do we think, are we able to speak to whether we've gotten to a stage where we can, if you go to the master facility list, right? What are they telling us here? They're telling us that Zambia has 3,745 health facilities. Have we gotten to a stage where the Ministry of Health has interconnected all of these health facilities so that they're able to actually generate reports, right? Using some nice dashboard about things like how many patients were attended to in all level 1 hospitals. Have we gotten to that stage yet? It's like, if you look at all the level 1 hospitals in the country, I don't know how many there are, 155 of them. have these been interconnected such that we're able to check in the month of January, X number of patients were attended to in the one hospital. In the month of January, we had X number of patients attended to, month of January 2026, by the way, attended to in level 3 hospitals across the country. And then you kind of like have a nice graph here. We see that the largest number of patients were at the University of Zambia Adult Hospital or something like that. Any thoughts or comments about that? Do we have such a scenario? I don't know if our colleague here, Dr. Mtinta, is around here. I wanted to ask, is Ngungu Hospital linked to some main, Ministry of Health hospital so that you're sending real-time data to the Ministry of Health? Can you hear me? I don't know if people can hear me here. It's so quiet on the Western Front here, but I don't know what's happening here. Any thoughts about this? Okay. Can you hear me though? In instances where I'm talking to myself here. I hope you can hear me.
We can hear you, Doc.
Okay, thanks, Tembo, sir. Mr. Uchi, there. Okay, that's fine. Hope this is making sense here. I guess, I don't know, to some extent, maybe not. But you also have things like so-called patient portals, right, in community systems. So tools that can be used for patient engagement and capturing, community level health data ideally. I'm not sure if may put Shash on the loop here, because I know he's going to introduce himself later on, but he works for CIDAS, and I know they have a number of kind of like community-centric systems that they use here. I don't know if he's still with us, he wants to talk more about that, but I wanted to mention that we're working on a project with a dear colleague of mine. You can look up this thing if you want to. It's a project that has a little bit of funding from the University of Zambia. So we got some seed money, and what we are doing is the argument we are making is that currently, for most of these health facilities, when it comes to lab tests or lab results, for instance, it's usually the case that when lab tests are conducted, they'll print them out for you. It's a horror story here. I remember I went to do some tests for I must say this story here because sometimes, it's through such interactions, like courses like this, that we work towards improving certain types of services, I guess. But there's a very horrible experience I had here recently. My father had a hernia, and thankfully enough, he was operated on. I think it's been 2 months now, or something, a month or so, from minor shock or something. Now, before that could be done, he is attended by a doctor, and the doctor says, "Oh, we need to do an echo and all sorts of crazy things here, right? You need to do an echo, ECG." And for the first time, I didn't know about is it HbA1c test or something like that. Shockingly enough, right? I tell you that that this was a doctor. Unfortunately, you won't be able to do it from right here, man. So I'm thinking, this is a level 3 hospital here. What is going on, right? I don't know. I don't care, right? I'm just escorting a patient here. Sad, but what do we do here? And then so, as I know, you just go at the reception there, and then this nurse says, you can go to these places. My immediate young brother is a medical doctor, so I asked him, he works from UTH, can this be done at UTH? No. Okay. I think he told me no, but also maybe there will be long queues. So we identify some crazy lab here. I've forgotten the name of the lab. A horrible place, that place. I'm never going back. We do the test. They tell us the test is going to be ready today. Okay? Nothing is happening. Please, I'll try and see if I can find the name of that place. I will never going back to that test. In fact, I've been meaning to tell our union here, because my medical scheme is with our union, Zalawi here. They should just remove that crazy place. They even charged me when they sent those things days after it was done, right? And this was an emergency case. It was supposed to be operated on like the following week or something. But anyway, so we go to Unilabs, right? Thankfully enough, it worked at Unilabs. We go to Unilabs, and the lab results, the only way you can get access to lab results is they print them out, right? So what we're doing with, sorry, I had to tell that story. What we're doing with this project, together with my colleague, Piela, right? Piela is here, he's the one leading the project. It's a small little project, but what we're trying to do here is we want to make lab tests more accessible, right? So what we're saying is, we can potentially build a layer, right, that will facilitate easy access to those lab results. So in essence, you're creating a patient portal, right, that will be used by patients to access their lab results. So if I go to Unilabs here, they just won't be printing the results. So probably create a profile for me so that I can access those results as and when required. And you begin to notice that this is something that is obviously desirable, right? Because if I'm doing this test from an external lab, all I would need to do is report to Minasoko to say I did this test from Unilabs, and then they sort of like integrate the results from Unilabs here with their system so that the doctor has access to everything. And it's quite common in this country of ours, is it? You go to UTS, they tell you our CT machine is down. So go to Levy. You go to Levy, our CT machine is down. Okay? Before you know it, right? You're doing your CT test from a different health facility. Some lab tests are from a different health facility, right? But you're being attended to a completely different health facility, In essence, those things, but if our platforms were interoperable, it would make life a lot easier. Anyways, but you also have operational systems, right? So these will be specialized systems that will be used for things like pharmacy management or billing, managing clinical trials as well. Anyway, now we begin to notice, if you look at all these different, key components or types of health data management system, you begin to notice that there is potentially something that is common amongst them, right? Chief amongst these features here is the fact that they must be interoperable. The idea behind interoperability here is simple. The different types of health data management systems must be built in such a way that they can speak to each other or they can exchange information. When I talk about interoperability, the example I like to give is something that is closer to home, is it? Everybody uses mobile money now, right? You are sending money via mobile money now. A key use case is, I use MTN myself. When I'm sending money to my mother, for instance, there's something interesting here. My mother uses Airtel. MTN and Airtel are two completely different organizations or companies. But it turns out that it is possible for you to send money from MTN to Airtel. You are able to do this because MTN money is interoperable, right, with Airtel money. And many a times, actually, you'll notice that the SMS that you will receive will have reference to NFS, right? I say, oh, your NFS transaction has been successful. It turns out that there is such a thing they call a national financial switch, right? Switch. By the way, in case you're interested in this, we're talking about interoperability, but I'm trying to use an example that is easy to follow, right? So if you look up national financial switch, I think there's a Financial Switch. There's a website dedicated to this, is it? I think it should be a website dedicated to this where you can find information about this idea. So a set of guidelines that would dictate exactly how, this sort of data has got to be exchanged, right? What you're doing here is you're exchanging data between MTN Money and Airtel, right? So these two systems are interoperable. What else? Well, you notice that when you are when you are logging into certain types of applications, I don't know if PG Online, right? When you're logging in here, you notice that there's a feature here. It says log in with your UNZA account. It turns out that the PG Online application is completely different, right? It's completely different to the system that is used to manage different email addresses at UNZA. But because these two applications are interoperable, you can actually log in with your UNZA account. And we've seen this manifest itself on so many different platforms. This is weird here, but there's a platform, a web application called Stack Overflow. And with Stack Overflow, if you want to log in, there's a feature that says log in with Google. I'm sure you've seen a number of such applications, is it? The reason why you're able to do this is because Google, for instance, is interoperable with Stack Overflow. So there's data being exchanged between Google and Stack Overflow. Or you can log in with Facebook, something like that. Right? So the systems must be interoperable. In other words, they should be able to exchange information. And this makes sense, right? It's like, forget about these systems when viewed from a national perspective. Think about them from the perspective of like a health facility itself. Your typical health facility, let's say UTH, will have a broad spectrum of things going on, right? Pharmacy, issues with the pharmacy, lab tests, payments, right? NEMA, cash, insurance, like Unzalaro and stuff. Radiology department will be dealing with medical imaging centric systems like the RIS and PACS. But what you notice, right, in all of these different things here, the thing that is consistent here is patient. Patient has got to pay money here. What is this now? A patient will need to go and collect medication from the pharmacy. A patient will need to do lab tests. A patient will need to make payments. A patient will need to be examined here, chest X-ray, CT scan, and all those things, right? Many a times, these things will be handled by different types of systems that are not interconnected. I know the Minister of Health is apparently working towards things like Smart Care. I don't know, they call it Smart Care 2 or something. I don't know what they're calling it, Smart Care Pro or something like that. I don't know how far they've gone with this. I know we're talking to, is it IMH or something like that, because we're trying to figure out how we could integrate this picture archiving communication system where we're building here with what they're doing with Smart Care Pro or something like that. But fundamentally, right, your typical health facility, it's not possible for you to integrate, because your healthcare ecosystem is so complex that it's difficult to integrate everything into a single system. What you do, though, is you can have these isolated systems that are interoperable. They can speak to each other, they can exchange data. So that fundamentally, a person like your general practitioner or a medical doctor here, a medical doctor would want to access this information from a central location so that they're able to prescribe medication. No, we've looked at your, we have access to your medical images in a single platform, yeah? And we've noticed here, I also have access to your lab results. And I think what is wrong with you is ABCD. so I've prescribed this medication. If you go to a place like Minnesota, actually, this is what happens, right? Your doctor will have access to most of this information in a central location. And it turns out that this is possible because these systems are interoperable. They're separate systems, but they're interoperable. They speak to each other, they exchange data. So it's a key characteristic in other words, right? Incidentally, this is such an integral part of health informatics, if I can use that phrase here, so much so that there's a dedicated course next term, I believe it is. There's a dedicated course we are calling this Health Informatics Standards and Interoperability, right? A whole course, and it's a core course. So in this course, one of the things we'll be discussing are interoperability protocols, because crucial to interoperability is things like when you're saying two systems are interoperable, you have got to agree on a protocol that will have to be used, right? When data is being exchanged, what protocol are you using? But also the data format, right? You know, how are you going to, how is the data going to be formatted when it's being exchanged? In the case of mobile money, if I can use this as well, they'll tell you, oh, MTN expects that or MTN will require that the number that you're specifying, the Airtel number that you're specifying must start with 260 followed by the number, right? Or it must just be 09 something something or 07 something something. It's a format idea. Typically, the specific data format would be like XML, you know, JSON, YAML, and all those wild formats that I use. But anyways, so interoperability. Another key feature here, I guess an advantage is data analysis and visualization, right? There should be a feature that facilitates the generation of information, is it? Graphs, maps, to facilitate decision making. Remember we mentioned that these tools are used to collect data, to process data, and to disseminate the data. Dissemination is usually in the form of graphs. Again, if I come here and look at the master facility list, right? We are disseminating this information, right? Through graphs. I know what this is here. Oh, the graph that showcases the different types of facility levels. We're disseminating information here so that we have an idea of which provinces have the most health facilities, right? Lusaka, apparently, followed by Southern Province. Now, we're not here to discuss what is that. We know why it's Southern Province. No, right? I don't know though. Followed by Southern Province or something like that. I never would have used this graphic. Oh, look at the map here, right? That shows us, right? Health facilities by province or something like that. Yeah. Chipata has one level 3. I didn't know there was a level 3 hospital in Chipata. How? Since when? The experts in the house, have things changed, the classification? Chipata Central Hospital is a level 3 hospital now? Wow. Shocked. Oh, wow. Okay. I don't know about that. I don't know, maybe it is though. Level 3 hospital. I didn't know there's even a diagnostic center. One eye clinic, one diagnostic center, one rehabilitation center, one dental clinic. This is sad. But anyway, so no, this is wrong. This information is wrong. You can't have one dental clinic in Chipata. Is that even true, colleagues? Right? Is that even true here? What I'm doing, by the way, right now is I am doing data analysis, is it? Visualization. This is the dashboard I'm using here. I'm drilling down by Eastern Province and I want to check Chipata. No, this is wrong. It's even a private hospital. I think this information needs to be, somebody needs to go and recollect this information and update this information. This is wrong here. How many dental clinics do we have in the country? 23. And out of the 23, we see that the vast majority of them are in Lusaka. There's one in Livingstone, one in Chipata, one in wow. is wild here. This is wrong. This is so wrong. But that's okay. Anyway, so what we're doing here is we're saying that one of the key features here is you do quite a bit of extensive data analysis, right? And this makes sense, right? You typically do data analysis when you're working with a lot of data points. And we see here that when you're dealing with health data management systems, you are really working with a lot of data points. For one, the average person will get sick at some point in time, right? Multiple times, actually, right? So you have records for multiple records for a lot of people, ideally. People get sick every day. If you just, I dare you to go to UTH here, such a sad place here, but you find a lot of people queuing up, doing all sorts of things, right? For you to make sense out of what happens there, you'd have to do some extensive data analysis, right? You'd have to use visual techniques where you're using graphs, dashboards, and maps to make important decisions. I have no idea what sort of decisions our colleagues make here. I know we have doctors in the room here, but hope you make decisions like, I think we need to push for government to buy an extra CT machine, because you see that the number of people coming to access this service has skyrocketed in the last 2 years. That's an important decision, I guess. But also, key features are security and compliance. Now, I know, you see, when we're talking about compliance, and I'm really looking forward for us discussing this topic. I don't know if it's Lumpa who's going to be discussing to you, or Mayumbo or something, but I think it's an important discussion. Sadly, and I'm saying, okay, I'm a bit skeptical about this because I know Lumpa at some point had told me that CIDAS was pushing to try and come up with legislation that is specific to health. Currently, we don't have nationwide legislation that speaks to how health data should be managed. There's nothing. Well, last time I checked, there was nothing, right? Like national legislation. And so the piece of legislation that we normally latch onto is the thing that I've just mentioned here. I can't remember this. Right? Data Protection Act, which is really not sufficient. So crucial to health data management systems will be issues to do with security and compliance. Security, because privacy is very, very important, right? I wouldn't want people to know about the illness that I may have, right? So my data has got to be secure. I wouldn't want my data to be just randomly shared with it's right there. And I so wish I was the one discussing this with you, but recently, right? Recently, there's something that has. Can't remember what is happening here, but there's a lot of debate that is happening here, like funding being linked to access to data and stuff, right? And I think Zambia is one of those countries that has, not that I don't know if we've actually rejected, but it's one of those countries which is a bit apprehensive about agreeing to this fund, right? Because it's linked to us giving up health data or something like that. I'm not sure if people can speak to this, but if you've heard about this, right? Yeah. Apparently we've paused data. I don't know what we expected to give up here, but apparently, yeah. Anyways, but security is quite important, and regulation as well. Now, when you talk about health data, it turns out that there are these international standards that we've got to adhere to, like HIPAA, for instance. But like I said, in terms of Zambia, there are things in the pipeline, but also there's the Data Protection Act that perhaps we can latch on to here. Anyways, but also one of the other key features associated with health data management systems here, issue of real-time access to data. So remember, we made mention of the fact that what typically happens with your health data management system are three key things, is it? Collection of data, processing of data, dissemination of processed data. Now, when you're disseminating information, right? The way these health data management systems work is that you actually have access to real-time data as data is being collected. You'd actually have access to real-time data, right? Yeah, so ideally, your typical health data management system is supposed to facilitate, instantaneous access to critical patient information to improve efficiency. There's an important, there's a procedure, there's this emergency case that comes through, and the patient needs to be operated on. A doctor can't operate on that patient, is it? Without, there's important information that you've got to do. Echo test here, want to do a ECG and all those things, right? The moment they're done, if you're working in a progressive health facility, the medical doctor or the surgeon or whoever needs to have access to real-time data on the fly, right? There are such emergency cases. Anyways, whether or not this is done in your typical health facility in Zambia is subject to debate. Please, any thoughts at your health facility? I know some of you here, you work at health facilities. Do you have access to real-time data? These are important conversations we should be having here at this level of study, right? Are you able to share with us whether you have access to real-time data, or this is not really real-time data? Any thoughts about this? Okay. Or maybe we don't know. I don't know. So with that being said, right, we looked at the key components and, with key features and advantages, right? Interoperability, compliance, security compliance, features like data analysis, real-time access to data and stuff. We've looked at the key components and types of health data management systems. We've looked at the important aspects associated with health data management systems, right? To wrap it in here, latching onto our definition, what we are saying is that your health data management system is a type of information system that is primarily used to collect health data. It's used to process health data. It's used to aggregate the collected health data, and is subsequently used to disseminate or present the processed health data in a form that aids organizational decision making. Okay? With that said, your health data management system is actually a type of information system. Your health data management system is primarily used to manage health data as opposed to operational stuff, right? Core functions of your health data management system is to collect health data, process health data, and disseminate or present processed health data as information, ideally. Okay? Now, just to put things in perspective here, using our case study here, the health data management system is used to collect data, process data, and disseminate processed data, or present information. So if you look at an example of picture archiving and communication system platform, we see that this thing is used to collect medical image data. Okay? The medical image data has got to be processed, cleaned, right, before it's actually added into this system called the PACS. Is it? This picture archiving and communication system platform is used to process the collected data, so that when you process this data, you'll be able to gain access to information like this, right? Details of the modality, each modality, these are the details. This is the study type linked to, I'm going to close this here. Patient ID is this, right? The date when this modality was, this medical image was actually generated is this. The institution that generated this. The referring physician who recommended this thing to be done. All this information you capture, right? And you're able to gain access to this because the collected data has been processed. It's been processed in such a form that you have meaningful information. When you're collecting this data, right, you go to the referring physician, he fills out a form. You're collecting data there at UTH. You go to the operator, the radiographer, he does the examination, and then he adds important information about you. When the medical image is deposited into this picture archiving and communications system platform, you then have access to information. This is information. Information that would be accessed by your radiologist in this particular case. Okay? And then what we see here is that this picture archiving and communication system platform, which is a health data management system, would then be used to generate reports. Like for instance, when we look at everything that has been collected, all these different medical images, I'm going to go back here. All of these different medical information about the medical images that have been collected here. We can generate reports based on this, right? Because we have details of the date when the study was conducted, which institution, is it adult hospital? Is it cancer diseases hospital? Is it PEDS, right? Is it internal medicine? Is it emergencies and stuff? I guess those are departments or something like that. We can generate reports, right? Can we look at where exactly these medical images are originating from the most? Oh, cancer disease hospital and stuff. What are we doing then? We are generating reports, is it? And making decisions once we generate those details here. What else are we saying? We are saying that a system like this UTH PACS platform should be interoperable with other health data management systems. At the UTH, although this is not done yet, but the PACS should be interoperable with the radiology information system, the thing that would be used to make a request for an examination to be conducted, the thing that would be used to upload the interpretation report once the radiologist is done doing what they're doing. In addition, it must be interoperable with like a typical health information system. Like in this particular case, it must be interoperable with that, what government, I don't know to what extent this has been done here, what government is calling SmartCare Pro or SmartCare 2, right? It must be interoperable. It must be able to exchange data with this thing here. I can sign up. I don't know. Oh, wow. I haven't signed up yet. Might as well sign up, I guess. I don't know. Wow. I don't know what this is. I don't have an NRC. I mean, because okay. So it must be interoperable as well. I want to pause here and try and ask if there are any specific questions about this before we proceed. Okay, if there are no questions, right? And I guess I want to suggest that, you know, this is, I don't know if we can do the request response cycle before we drill in here and look at the specific aspects here. Some of these things, maybe I can probably leave them out because it's, I guess there's too much to tell. I don't know. I would want us to, because what I've done, by the way, is I'd organize this in such a way that once we provide a bit of context here, we're supposed to spend quite a bit of time discussing like the information technology layer in great detail. So we look at the different types of computer systems and stuff. And then afterwards, we are supposed to start looking at software. You know, we look at yeah, but I think communications infrastructure, data sources. I may have to scale this down a little. I think some of this may not be maybe very, very necessary, but maybe it would help in helping us understand what is going on here. But if there are no questions, I want to proceed here, right? And maybe before we zero in into the specifics of, you know, the key aspects of the health data management system, right? Specific details about hardware, you know, software, communications infrastructure, data sources, people, and procedures. I guess it becomes important for us to kind of define certain important things here, because we kept on mentioning here. If you look at our definition here, a health data management system is a category of information system that is primarily used to collect data, process data. The question is, And then we're talking about information and all those things. What exactly is data and how does it differ from information? So I thought we'd have a discussion about this, right? Just to make that distinction ideally here. But just to mention here that your typical health data management system here would be used to collect, like we said, collect raw data, which will then be processed and converted into information, right? And it turns out that what is important about information here is that typically that information will be used to, there's a hierarchy I want us to talk about here. The information is subsequently used to derive what's called knowledge, and certain school of thoughts have said using knowledge here you can derive what's called wisdom ideally, right? So there's this pyramid idea, right? That speaks to how you move from data all the way up to wisdom here, right? So the fact that you typically would be in a position where you make decisions or a judgment about a particular aspect of health data in this particular case using information, is it? Right? The information itself is derived after data has been processed. And it turns out that the data is nothing more than raw facts. At the very top here, right, what we call our shared understanding will lead us to wisdom ideally, apparently. Okay, so what we're saying here is that so-called data comprises of raw facts, is it? That ideally will not have any sort of context. Okay, and I think this definition here is best understood from the perspective of our example here, right? Our PAC system. I am sick, and the doctor says you need to go and get examined, right? I need to see an X-ray or something. You see, the doctor will fill out a request form, is it? Indicate their name, their department, if it's at UTH, which hospital they are from. Is it internal medicine, adult hospital, pediatrics, and all those things? Mothers and newborn, whole 9 yards, right? The details that are being included in that form is what we're calling data, is it? They are raw facts there's no context here. Like, for instance, one of the things that will be indicated there is the patient name, right? So they will have something like patient name is L. Piri. If you look at just L. Piri in isolation, this thing is not useful in any way, right? There's no context. It's like, what is L. Piri, right? Is this the name of the patient? Is this a referring physician, right? So data comprises of just raw facts ideally, right? Or raw bits without any context, there's no context. Information, on the other hand, will comprise of these raw facts that have been processed and they've been well organized and structured to provide useful context. So, for instance, when you look at that request form, if you look at the information holistically, there'll be details like patient ID, patient name, referring physician, date of birth, and maybe as things happen here, I know I have a colleague who at some point was telling me he had a very nasty experience. Sad story what happened. At some point he was on a bus, apparently according to him, a couple of years back, and he's on a bus and then he just felt numb, right? Is it left side or right hand side or something? He didn't know at the time that what he had experienced was a stroke, actually, a colleague from work. So he brushed it aside and just thought it was just one of those things. And then they arrive at, I don't know if it was Limata or something. He attempts to get out of the bus and he can't, right? He just fell down, So anyways, he finds himself at UTH and he was narrating this nasty experience where there's a crowd of people coming through and he was used as a case study. It happens a lot at UTH, right? So there are these trainee doctors, I don't know if there are interns around, and they're discussing him as a case or something. So what they would be doing then is that when they're discussing a patient like that is, oh, so this is patient Lighton Piri, adult male, right? Exhibiting signs of blah, 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 blah. At that point, right, you're making reference to raw facts without context to derive information, is it? So there's a bit of context here. Adult male, and it's adult here from the date of birth, is it? It's male here because gender information has been captured, and all those things. So when information really comprises of its processed data, which is organized and structured, and usually information will include these raw facts that have been collated together, right? They've been combined, they're being looked at holistically, ideally. Okay? Knowledge consists of information that has been synthesized and analyzed to enable end users to make decisions. Adult male exhibiting, I don't know if it's what he's exhibiting here. And then the doctor will use their knowledge, is it? Right? Based on these symptoms and stuff, they'll say, we suspect they have ABCD. And then wisdom apparently results from a combination of knowledge and domain expertise and experience, right? So you notice here that the wisdom exhibited by a doctor that has 10 years of experience, right, is going to be completely different, is it, from that exhibited by somebody who just started 1 year of experience, right? If that makes sense. Anyways, now to try and perhaps put things into perspective again, looking at data, information, and knowledge, I guess, I don't know about wisdom part here. It's like if we are to consider data, information, knowledge, and wisdom as it relates to our case study, health data management system, UTH PACS platform here. Data could be details to do with the patient ID, date of birth, gender, or patient sex in this particular case, a study date, right? Institution name and stuff here, right? All of these individual bits and pieces of information are what we're calling data, right? No context, right? The information, however, right, is details about this patient when looked at holistically. So in addition to this meta information here, these DICOM elements, when these are combined with the medical image, you'll be able to extract information, right? The actual raw facts. So in other words, the meta information for these, by the way, these are anonymized, these are fictitious names. Inonge Mutua chest here, these are fictitious names here. Oh, I need to log in, I guess. If I access this data like this, right? This becomes information when I come here, and I'm a medical doctor, I guess, I don't know. When I come here and I say, I then want to, I don't know if I'll be able to access this details here. I don't download the zip file here, copy zip. Right? When I come here and I'm viewing the X-ray in this particular case, right? So this thing I'm viewing together with the meta information will enable me to come up with information, is it? Right? When viewed collectively, yeah? And then the knowledge in this particular case would be using the information, this medical image and the meta information, I'll come up with something like adult male, LP, he exhibits signs of blah, 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 or something like that, right? If I'm a highly experienced medical doctor, I'll use my wisdom to maybe try and come up with interesting things, like based on past cases that are similar to this, this should be the next course of action, ideally. Anyways, and I guess if we are to look at it from the perspective of these different aspects here, again, we see that this piece of software called the picture archiving encryption software 2 is associated with hardware, right? It's installed on a server computer system. There's a series of application software and system software associated with it. Because it's web-based, there's communications infrastructure that is required, data is persistently stored in a database, SQLite or PostgreSQL, There are people that we interact with, these medical doctors, radiologists. There are procedures that govern how this thing is supposed to be used. Okay, I'm gonna pause here and say that the next time we meet, hopefully tomorrow, if tomorrow is a bit of an issue, we can stretch Sunday maybe, Sunday afternoon. Sunday I'm probably available around, I'm available around 17 if you want us to do Sunday instead of Saturday. Usually, in case the Adventists here, if Saturday is just a horrible time to have class, we can probably stretch it to Sunday. But what I'm trying to do is I'm trying to quickly get my part out of the way so that when Lumpa or Mayumbu comes in, they can, they can seamlessly take over or something. Are there any questions so far? I'm trying to check if, yeah, I think Sunday afternoon will work actually. So beginning, I should be available from 17 if it's Sunday. If it's tomorrow, 14 or 17 hours, let me know. We'll continue with, how exactly, what typically happens when we are interacting with the typical health data management system. We'll briefly look at the request response cycle, and then my thinking is that we start going through this technology layer or these aspects in great detail, but try and see if we can maybe strip it down to the bare bones so that we immediately jump to, I want to draw attention to this. What we are doing here is this, is it, right? You need to jump to the health data life cycle and talk about data governance, the 4 pillars of data governance, legal and ethical frameworks, and stuff. So I may decide that we prioritize those things as opposed to looking at the gory details of the 6 aspects of your typical health data management system. All right, unless if there are any thoughts or questions, I think we can probably leave it at that. I want to suggest. I'm surprised that I don't know if it's because it's a Friday, people are not, people are not engaging here. But if there are no questions, thank you very much. This slide deck, I'm going to dump it on, I will put it on the Google Classroom site. And then also, I hope I was recording this. I always try to record my lectures just in case. But it appears I wasn't. Wow. This is shocking. Wow. I thought I was recording this. Huh. Okay, that's fine. I'm recording it via Google Meet though, TODV, but I always have a backup to record it locally because sometimes this thing is not reliable, right? Yes. But that's okay. All right, thank you very much, everybody then. If there are no questions, we shall see you when you see me. Hopefully tomorrow or Sunday. I shall be waiting to hear from you regarding when, I've noticed when I say I'll be waiting to hear from you, that sometimes there's no feedback. So what I shall do is, if there's no feedback, you just see an email to say, I've scheduled class for this time or something like that. Thanks. Good night.
Thank you.